Hello and welcome class. So in last class we have studied about uh, what is pressure and what is thrust, and we have completed the first part of this chapter. In second part, which is all about fluids, we have first studied what is thrust. Thrust is the perpendicular force from the surface, and what is pressure? Pressure is thrust per unit area. We were understanding the question that why when we stand on a loose sand we start sinking, but we when lie down on that loose sand we stop sinking. And the answer was that when you are standing on the sand, the magnitude of the thrust is same, but your surface area decreases, and because your surface area decreases, pressure increases. And when you lie down on the loose sand, your thrust or perpendicular force value is still the same when you were standing, but your surface area increases. That's why your pressure decreases in that case. Let's learn more about pressure. The formula of pressure is thrust per unit area. The standard unit of thrust is Newton, whereas the unit of area is meter square. Okay, so the SI unit of pressure is Newton per meter square. A scientist named Pascal, in honor of that scientist, the SI unit of pressure is called Pascal, denoted by PA. So it has two standard units. One is Newton per meter square and other is Pascal. 1 Newton per meter square is equals to 1 Pascal. Is it clear, class? Let's understand the phenomena of when we stand or surface area decreases, pressure increases, and when we lie down on the sand, surface area increases, pressure decreases. By an example, let's consider a wooden block is kept on a tabletop. The mass of that wooden block is 5 kg and it has dimensions of 40 centimeter, 20 centimeter, 10 centimeter. We have to find out the pressure exerted, and these are the two cases. One is a vertical case, okay, where object is placed like this, so it has very less surface area touching the table. This will be the length and this will be the breadth. And case number 2 is when an horizontal is placed, when that object is placed horizontally, okay, horizontally, the length is 20 centimeter and its breadth is 40 centimeter, touching the surface of the tabletop. We have to calculate upthrust and pressure in these two cases. So how we are going to calculate the thrust? Thrust is force and force is mg. Mass, the given mass is 5 kg. So upthrust will be 5 kg into 9.8 meter per second square. This will be the upthrust. Okay. And now we have to calculate this will be the upthrust, and to calculate pressure we have to first calculate the area. In first case, the surface which were touching the table top was 20 centimeter into 10 centimeter. What will be the surface area of it? We have to convert this quantity into meters, so 20 into 10 meter square. So area will be, for this case, 0.02 meter square. And for the other case, what is other case? Other case was the surface, this one surface touching the tabletop, 40 centimeter into 20 centimeter, okay, which is then the area will be 40 into meter square. Area is 0.08 meter square. So the surface area touching in the horizontal case is 0.08 and surface area touching the tabletop in vertical case is 0.02 meter square. We have thrust, we have area, we can easily calculate the pressure by using force per unit area or thrust per unit area. Mass is 5 kg, dimension is given. Then the thrust is force into mg, the value of m is 5 kg, g is 9.8, force is 49 newtons. The area in first case, as we calculated before, is 0.02 meter square. Is it clear, class? Area is length into breadth. Length was 20 centimeter, breadth was 10 centimeter. We converted centimeter into meter. So for the final answer is 0.02 meter square. So the pressure for the vertical case is 49 divided by 0.02 meter square. Pressure is 2450 Pascal or Newton per meter square. This is the pressure for first case. In second case, the surface area is 0.08 meter square. So the pressure is, say, 49 divided by 0.08 meter square. Pressure is 612.5 Pascal. So from this example, you can clearly see that when surface area is small, pressure is high, because in this case, first case, the pressure is 2415 Pascal, and for the horizontal case, the pressure is 612.5 Pascal. Okay. So you can clearly see that when surface area decreases, pressure increases. Thus, the same force is acting on smaller area and larger area, but when area is small, pressure is high, and when area is large, pressure is small. This is the reason why we made the tip of the nail pointy. Why? Because it will have less surface area, and less surface area means high pressure. So this nail will be able to easily penetrate the hard concrete and get stuck into the walls. Okay. And that is why knife have sharp edges, because if they have sharp edges, it means it has lesser surface area, so it will create high pressure on fruits and can cut fruit easily. And that's why buildings have wide foundation, because buildings are very massive, they have very large mass. If they are placed at a small pointed foundation, then what will happen? The building will start sinking. That's why we made the foundation of buildings wider, so that the pressure on the surface decreases. Clear, class? So we have completed the topic thrust and pressure in a solid. Now we are going to start pressure in fluid. First of all, what is fluid? Gas and liquid are known as fluid because they can easily flow. Their particles are not tightly bound. So all liquid and gas are fluids. A solid exerts pressure on the surface due to its weight. Okay. How does a solid exert pressure? Solid exert pressure due to its surface area and because of its weight. Similarly, fluids have weight. Fluids also have weight, and they also exert pressure on the base. For example, this is a glass and you have filled it with liquid, water. So this will be the surface area touching the ground. So liquid will exert the pressure on the base or on this surface and wall of the container also, these walls of the container, okay, in which they are enclosed. Pressure in any confined mass of fluid is transmitted undiminished in all direction. Okay, the pressure in any confined mass of fluid, okay, is transmitted in all the direction. So liquid gives pressure in all of its direction. does not require that liquid will exert pressure in downward direction. In any direction it can exert pressure. Okay, that is pressure in a fluid. Now we are going to start a new topic named buoyancy. Okay, have you ever had a swim in a pool and you felt lighter? Okay, have you ever swim in a pool and you felt lighter, like anything which is pushing you upwards? Have you ever drawn water from a well and felt that the bucket of water is heavier when it is out of the water? Have you ever drawn water from a well and felt that the bucket of the water is heavier when it is out the water? What it is saying that when the bucket of water, which is uh, full with liquid, and when you have placed over it water, you feel it lighter, but when you start pulling it upwards, okay, you will felt that the bucket of water was heavier when it come out from the water. Have you ever felt it? Why it is happening? Have you ever wondered why large massive ship which are made up of iron steel does not sink in the water, but iron and steel in a form of a sheet would sink? Okay, huge ships, okay, let's say Titanic, which is a very huge ship made up of iron, steel, okay, okay, does not sink in the water, but a sheet of iron sink or nails sink in the water. Why it is so? To answer these questions, we have to understand what is buoyancy. So first, let us learn about what is buoyancy, then we will answer all these questions. We will understand buoyancy by one activity. Activity number 9.4. Take an empty plastic bottle. Close the mouth of the bottle with an airtight stopper. Okay. Put it in bucket full of water. You will see the bottle floats. Let's suppose there is a bucket of water and you have a plastic ball in your hand. Simple example. And you throw that plastic ball in the water. You will see that the plastic ball, what will do plastic ball? Plastic ball will float. Okay. Now what you are trying to do, you will try to push this plastic ball inside the water. What you are doing, you are pushing this ball inside the water. Then you will feel that ball is not sinking, it is pushing your hands upward. Okay, so this ball does not drown, it you will feel a upward push by this ball, and this ball will continue floating. You will push more and more, you will feel more upward force to your hand. Okay, and you will find it difficult to push deeper and deeper. Why it is happening? This indicate that water exert a force on the bottle in the upward direction. Okay, this water, you are putting a force by your hand, but you are feeling an upward force. And from where this upward force is coming? This upward force is coming because of this water. It means that water exert a force on the bottle in the upward direction. And this upward force expel this object for drowning. Okay, the upward force exerted by water goes on as the bottle is pushed deeper till it completely immersed. Okay, this force will continue till the object is completely immersed. Now release the bottle. when you will stop applying force on the object, what you will see? If you stop applying the force on the ball, what you will see? The ball will bounce back to the surface. So what does it mean? Does Why does gravitational force not acting on the ball? Why the ball is not sinking? Okay, why it is still floating? We have applied force. Okay, we are feeling an upward force on the body. Why this force is working against the gravity? Why the bottle or that ball does not stay immersed in the water after it is released? Why it bounce back to the surface, to the earth, surface of the water? How can you immerse the bottle in water? So the thing is, gravity is there. Okay, this is your ball. You are applying force. Gravity is also pushing it in downward direction, but you are feeling an upward force, okay, because of water. The water exert an upward force on the bottle or the ball. So the water is applying a upward force higher than your applied force and gravity. Thus, the bottle is pushed upwards. We have learned that the weight of an object is the force due to gravitational attraction of the earth. Weight of an object, why weight exists? Because this is a mass. Gravity is pulling it in downward direction. Weight is mg. Okay, so we know this thing. But here, when a bottle is immersed, the upward force exerted by the bottle is greater than its weight. The upward force which is exerted by the water is greater than the weight of that object and greater than gravitational force. That's why that object rises up and reach back to the surface of the water. To keep the bottle completely immersed, the upward force of the bottle must balance the downward force of the which you apply on the bottle should balance the upward force exerted by the liquid. Okay, and this can be achieved by external applying the force acting downward. And how can you achieve it? You have to apply more force in downward direction to cancel out that upward force because of that liquid. So this force must be at least equal to the difference between upward force and the weight of the bottle. And that upward force exerted by the bottle, okay, the upward force which is exerted by any object due by the water is known as upthrust or buoyant force, and this phenomena is known as buoyancy. Clear, class? So this is the definition of buoyant force. It is an upward force exerted by any object when it is immersed in an liquid. In fact, all objects experience a force of buoyancy when they are immersed in the liquid. Okay? When you jump in the pool, you came back on the surface by yourself. It is because of that upward force exerted by your body because of water. The magnitude of buoyant force depend on the density of the fluid. The density, what is density? Density is mass divided by volume. Okay, this is density. So the mass of a normal plastic ball is around 35 kg and its volume, the volume is very less. Uh, so its density is very less. Okay, and the density of water is very high. So whenever you try to push a plastic ball inside the water, its density is very low. Okay, and the density of water is very high. So you will exert a very high upward or buoyant force because of the density. Why object float or sink when it placed on the surface of the earth? Let us arrive on that questions which we have asked in the starting of this topic, buoyancy. Okay. Take a beaker filled with water. Take an iron nail and place it on the surface of the water. You have taken a beaker filled with water. You have placed a iron nail on the surface of the water. According to you, what will happen? Obviously, this nail will sink. Okay? This nail will sink. The force due to gravitational attraction on the earth on the iron nail pulled it downward. The upthrust of the water on the nail, which is pushing it upward, but the downward force is very very much greater than that upward force, so that the nail sinks. Okay, is it clear why the nail sinks? Okay, but when you place a cork, it start floating on the surface of water. It floats, but it sink. And why nail sink and cork float? It is because of density. The density of iron nail is very high in comparison to the density of water. Okay, because because the mass of iron nail and it's have very less volume. Okay, what is density? Density is mass per unit volume. The mass of iron nail is very high, the volume of iron nail is very low, so its density is very high. And because its density is very high in comparison to water, so what will happen? It will reach the uh, bottom of that beaker, whereas the density of a corkscrew is very low because it has larger volume and lesser mass. So the density of corkscrew is very low in comparison to density of water. So corkscrew will float, but the iron nail will sink. Okay, when you will take a piece of cork and put it on that water, it will float. The cork will float, but the nail sinks. It is because of their density. Okay, so you should first know what is density. Density is mass per unit volume. Mass per unit volume. Okay, so if any object has lesser density than density of water, it will float. But if any object has density larger than the density of water, it will sink. This means that the upthrust of the water on the cork is greater than the weight of the cork. Okay? So the cork will float. The density of iron nail is much more in comparison to the density of water. So iron nail will sink. Because the density of iron nail is more, it means that the upthrust exerted by the water on the iron nail will be less, okay, than the weight of the nail. So it will sink. Therefore, object of density less than the density of the liquid or water will float, whereas other object, so density of object is less than density of water, what will happen? It will float. But if density of object is greater than density of water, what will happen, it will sink. Simple phenomena. Okay. So uh, from here, it is clear to all of you that why cork is floating but iron nail is sinking. Then why large ships do not sink? They are also made up of water. Okay. They are also made up of same material as iron nail, iron. Okay. And their mass is very much larger than comparison to the iron nail. But iron nail is sinking, but the ship does not sink. Why? And the reason is surface area or pressure. So if any object sink or float depends on two quantities. One is density, second is pressure. Okay. The surface area of large ships is very high. Okay. Very large surface area. So the upthrust force will get larger area to apply. Okay. And when area is large, pressure is very low. And because pressure is very low, so it will float. The ship will float. But the surface area of a iron nail is very small. So it has very large pressure. And because it has very large pressure, so it will sink. So, if any object is floating or sinking depends on two phenomena. One is density, second is pressure. I hope it is clear to all of you. Let's solve some question. Why is difficult to hold the school bag which have strap made of thin and strong string? Okay, let's suppose it's a school bag. Okay, it's a school bag. A normal school bag. Okay. These are the straps of the school bag. Let assume you have a school bag which has very thin straps. Very thin straps. So you will find that those school bag which has very thin straps are very difficult to hold on your shoulder. Why? What will be the answer of it? And the answer is, we know that pressure is equals to thrust divided by area. Okay. Thin straps has smaller area. Okay, smaller area of contact between your shoulder and that strap. So pressure will be high. So your shoulder has to exert lot of pressure because of this thin strap. That's why it is difficult to hold a school bag. Is it clear, class? It is difficult to hold a school bag having a thin strap because the pressure on this shoulder is quite large. This is because the pressure is inversely proportional. Pressure is inversely proportional to the surface area on which the force is acting. Smaller the surface area, larger would be the force. And the case of thin strap, the contact surface area between that strap and your shoulder is very small. Hence, you have to exert more pressure on this shoulder. Okay, that's why bags have large straps. Okay, not thin straps. Next question is, what do you mean by buoyancy? It's a direct definition based question. The upward force exerted by the liquid on an object is known as buoyancy. The upward force exerted by a liquid on an object that is immersed in it is known as buoyancy. This is the definition of buoyancy. I hope this question is clear to all of you. Question number 3. Question number 3 is, why does an object float or sink when it plays on the surface of the water? And what is the correct answer according to you? Why an object float or sink? The major factor is density. Okay. If an object has less density, it will float. And if If it has large density than the density of liquid, then it will sink. If the density of an object is more than that of the density of liquid, then the object would sink. This happened because in this case, buoyant force that is acting on the object will be less than the force of gravitational acting on the object. So you know density is factor, okay? More the density, object will sink, okay? Less the density, object will float. Okay, so in today's class, we have studied about pressure in fluid and what is buoyancy, and we have tried to answer few questions. In next class, we will study a topic named Archimedes principle, and with that topic, this chapter will be completed. I hope you have understand today's class. So we will meet in next class. Thank you.